This is Precalculus Concept 18b. We're going to be looking at the graphs of exponential functions. There's 4 boxes. Box 1 is an example of 2 different exponential functions and their graphs. I've got these pictures here from Desmos. Graphing calculator is also a great option when you're asked to graph an exponential function. But let's take a minute and think about how we might do this by hand as well. So as always, we've always got the option of plotting some points to think about what our functions might look like. I'm going to do just a few points here and think about what I might get if I stuck in -2, -1, 0, 1, and 2 to this particular function. So when I stick in -2 to the function, my base is 2, my exponent is the -2, and we want to remember that negative exponents reciprocate, so this ends up being 1/4. Right? 2 to the negative first ends up being 1/2. 2 to the 0, I hope you remember, is just 1. And then 2 to the first, we'll do that in our head, and 2 squared is 4. So by taking a minute, I can kind of plot these 5 points. 1, 2, 3, 4, 5. And I've got some idea of what the function looks like. It's also helpful to think about what happens if I kept going. So if I kept going in the negative direction, notice I just get smaller and smaller fractions if I kind of went backwards here. And my next one would be 1/8 and 1/16. And so what happens here is that the graph just goes infinitely far to the left but levels off. That's actually a very important property of exponential functions. So you'll never actually get to 0, but you'll just have smaller and smaller fractions. And as I continue this way, as my inputs become bigger and bigger and bigger, my answers would just get bigger and bigger and bigger. So another property of exponential functions is that on the other side they grow very quickly. So on one side they level off, and on the other side they grow and grow and grow. Okay, we could do the same thing with 1/3 x to the third. Sorry, 1/3 to the x. Let's do that a little quicker. But once again, if I wanted to plot some points, I could think about some values of x and y and how they would behave. This time when I stick in -2, 1/3 to the -2 power, remember that a negative exponent means reciprocate, so that's actually going to be the reciprocal of a third, which is 3 squared, so I get 9. And 1/3 to the negative first is actually just 3. And plugging in 0 still gives me 1, plugging in 1 gives me a third, and plugging in 2 gives me a 1/9. In this example, we see kind of the opposite behavior. If I go further to the right and keep going, it's just going to level off and approach 0, but never reach it. Right? 1/3, 1/9, 1/27 would be my next integer value. And the left-hand piece goes shooting up. Okay, so all exponential functions can be slightly different, but they're going to have some similarities, which we'll talk about in the next slide. All right, I have 5 different exponential functions graphed to illustrate this concept. We've got one with base 1/6, one with base 1/2, one with base 5, and one with base 2. All of them obviously look a little bit different. However, they all have many of the same properties, which we'll discuss below. So no matter what, a exponential function, a basic exponential function, is going to have a domain of all real numbers. You can see that's true for all 4 of these. The inputs, the x values, are not limited to anything. They just go on forever. The range for each and every one of these is the same. Remember we said there's kind of this leveling off line at 0. And if you think about it, none of these graphs would ever reach 0, but rather be strictly greater than 0. That's common to all 4 of these and every exponential function. The y-intercept here is 0, 1, and that's going to be true for, again, for any basic exponential function. By the way, this is for all functions of this form, y equals b to the x power. Okay, if you have a b value that's greater than 1, like 5 or 2, you want to remember that the shape of the graph is going to be rising on the right and leveling on the left. So that's a good way to think about it. And if you have a fractional b, something that's between 0 and 1, it's going to be the opposite. It's going to be leveling off to the right and rising to the left. That's a very important thing to help you distinguish between what's called exponential growth, rising, and exponential decay, which is falling. We want to remember the term one-to-one. All basic exponential functions are one-to-one, which means they pass a horizontal line test. And then finally, this dotted line here that the graph gets closer and closer to is y equals 0. And all basic exponential functions have y equals 0. Okay, take a minute, jot down these characteristics of y equals b to the x. They're important ones to remember when dealing with basic exponential functions. Alright, just like our other functions from first semester, if we know a basic function, then we should be able to do transformations of that function. So just like our absolute value function or our x squared function, small changes in the function just make small changes in the graph. So f of x equals 2 to the x plus 3. If I take my base function and I think about the difference, all the y values are just going to be moved up 3. So I'm going to take every single one of these points, move it up 3, and draw my new graph. I also want to keep in mind that my asymptote, which was at y equals 0, is also shifted up. And so I have a new asymptote of y equals 3, and I want to show that as best I can in my answer. And so here's what your graph would look like, a little bit rough there, but you get the idea. Every single point is moved up 3 units. Okay, over here on the second example, I've got a g of x equals negative 2 to the x. Now notice my base is still positive 2, but I have a negative on the outside. You should remember that as a reflection graph. So very quickly, I'm just going to think about all of these points as if they were reflected through the y-axis. I'm going to run out of room here. My asymptote is going to stay the same because that actually is my mirror or my reflection line, and so your graph's going to look something like that. We're going to practice transformations a lot in class, but you should remember all your stretches, shifts, and reflections as they might apply to a basic function like 2 to the x or something else like b to the x. Alright, this is a U-try. I want you to look at the 4 functions given and think about which one of them most fits the graph shown here. A couple things to take note of. This is a graph that's rising to the left and falling to the right. That's important to consider. And also your asymptote here is at y equals 4. I'll give you that hint. So look through your answers and think about which one best fits. Alright, you should have picked the function that had a fractional base, a base that was between 0 and 1, and one that had been shifted up 4 units, so 1/3 to the x plus 4 was your best answer.